All right, so welcome back. Continuation of polynomial functions. Now I want to talk about zeros and roots. Now, zeros and roots you have studied to quite an exhaustion with quadratic functions. So here, actually, if you take a look at this, so here's a quadratic function that you have. And the idea behind finding the roots or the zeros of a function, in this case the quadratic, is basically setting the function equal to 0. So if you would set this equal to 0, like this, you would want to find, okay, well, can you solve for x for all the values of x such that this, in this case, this right-hand side right here is going to equal to 0 on the left-hand side. And that was it. Now, if you're thinking about functions, what that means is you're taking your function and then you're trying to see where that function intersects the function, which is just a flat line at 0, basically. Okay, those are your x-intercepts that you have along the line. And that was pretty much it. Now, in quadratics, we had numerous ways of finding it. One way, if it's possible, you can maybe even factor it. So like this. So these two are actually equivalent. And then from there, well, if you have it in factored form, then it's pretty simple, because then you can take each factor, set each factor equal to 0, and then isolate, and you will find exactly the value. So for instance, this one, one of the factors gives us x is equal to 1, which would make that equation 0. And that would be one of the zeros or one of the roots of that particular function. Now, when you start spanning this out and you start considering polynomial functions, which aren't as easy because of the fact that, well, they're not quadratic, meaning that the order doesn't have to be set to 2. Well, what if the order was 3, right? Or what if the degree of the function was 4 or 5 or 6 or 7? In those cases, trying to factor is not that easy. Now, you might say, well, in quadratics, we kind of could have used maybe a quadratic formula, and then we were able to figure things out. Well, again, if you take the order or the degree of the polynomial higher and higher and higher, it is actually much harder to be able to do that. And most of the time, as people go through math, they start utilizing other tools to see. Now, in school, sometimes your teachers will give you polynomials that maybe are factorable in some way, and or might give you some hints, but those in reality are kind of school-related questions. In reality, if you take the questions or any general polynomials, you don't know what the heck is going to happen to the zeros or roots. And so if you do that, so if you take these, and they might be very arbitrary, and you set these equal to 0, and then you say, well, can you find the roots or zeros of this polynomial such that it equals to 0? Then you're probably at a tough point to trying to figure it out. But in general, what I would want you to think is, remember, go back to the quadratics and always think, what did it really mean to find roots or zeros of a function? And what it means is you take the function and you want to see where it intercepts, okay, the x-axis, or just the function, the simplest function, I guess, or one of the simplest, which is just a flat line equal to 0, right? That's really what you're trying to find. Now, can we get maybe some pattern of all the things that we started to learn about polynomial functions about the actual roots or zeros? So if we can't exactly find them, can we kind of get an approximation, or at least know, do they exist? Do they not exist? How many do we have, right? So those are kind of legitimate questions. And I'm going to try to answer those questions here for you. And then you can play around with a tool like kind of Desmos or any graphing tool to be able to see that. And I'm going to give you a couple of examples to play with as well. So in general, okay, as you study polynomial functions, you notice the pattern that we almost continuously separate these into the pattern where the polynomial is of even order, or if the polynomial is of odd order. All right, so this is what we have. So either this or that. Now you do see that, right? This even and odd, even if you're talking about the domain and range. Now you notice, or if you recall, that the range for even is not necessarily the entire right, your y outputs. So it's not the entire number line that you have. There is some kind of maybe a minimum and then you're above, right? Or maybe there's a maximum and then you're below for that range. So what would that tell you? So think about in terms of the zeros, you know, those crossings of the x-intercept. If that minimum, right, is above the 0 line and then it opens upwards, then you never are going to get any intercepts at x is equal to 0. So there won't be any zeros or roots of that polynomial. If that minimum maybe was below, then it opens upwards, then you know you're guaranteed that you're going to get some that are going to cross through. So it turns out then when the order of the polynomial is of even order, it might be that you might have 0 crossings, okay, or 0 of these roots. You might have a maximum of basically n of the roots. So it can span quite a lot. So it can be either none or it can go all the way to as many as you like. So for instance, so this one above, which is a quadratic, okay, so in this case we actually would have 2 roots, and notice that n was equal to 2 and we actually had 2, right? But if that quadratic was placed somewhere else, maybe we wouldn't have that. Now, is it possible that for odd, in this, if the degree of the polynomial is odd, can you actually have 0 roots? Well, let's think back of the range that you learned. And again, if you're talking about the range and you forgot, I'll put up a link up above there if you want to review that for yourself for polynomials. Well, the range is the entire number line for all odd polynomials. So if it's the entire number line, that means that there must be at least one crossing through that x-axis. Because if there was no crossings at all, then the range couldn't have been the entire number line, right? So it's interesting that if you're talking about the roots or zeros here, so the minimum amount is going to be at least one root or crossing of that 0. So you're going to have at least one. And then, just like your even, you're going to have a maximum of n. Now, again, it doesn't necessarily mean that you're always going to have 1. It doesn't mean that you're always going to have n. That will depend on the actual polynomial that you carry. But these things are very good things to keep in mind. So for even, notice that it can have 0, meaning none. And then for odd, there has to be at least one crossing. And then you can find how many other zeros. Now, if it's something complicated, so for instance, I have a few examples here. If it's like this, well, good luck trying to factor these things out and then trying to find out what the actual 0 crossings are. So what I recommend, especially when you do, okay, run into the fact that you can use some graphing tools, don't forget that all of these, again, are just simply, well, let's try to see, because we want to map these and see where the x crossings are. So all of this is supposed to be equal to 0, and we want to find the values of x. Let's do that. So I'm going to bring out here. So let's say I'm going to bring out right here. Okay, let's bring out decimals, and I'm going to try to plot these on decimals. So the 0 crossings that we carry, I'm going to call this, I don't know, let's say h of x is equal to 0. All right, so that's my flat line. That's where I want to see where the crossings are. And now I'm going to put this complicated function in here. So 0.2, I guess this is x cubed plus 0.4 x squared minus 7x, and then minus 3. All right, and notice this is what you have. And so I'm going to make this the entire screen, so just so that we can see it. So in this case, well, how many crossings, how many zeros or roots would I have? Well, as you can see, it happens in actually 3 different places. Now, it's not going to have more than 3 because the order maximum is 3 of this polynomial. And we can find these. So this is 1, now this is another one, and this is the other one. Now, of course, these are most likely some approximations of them. So it looks like this can be possibly factored out. We can do that. But my idea within this video is to show you intuitively what these things actually mean. Now, let's take a look at another example. So let's say this one. Okay, so here we have negative 0.6x to the power of 6, right? So that's even. So this, okay, so has the highest order of, okay, of an even. So that means it could possibly be 0 or a maximum of 6 crossings or 6 zeros or roots that we'll have. Well, let's see what this will actually yield to us. So if I go back again, and if I take out decimals, just as I did in the previous one, so let me flatline this one, all right, and let's put this g of x in here. Now this one's going to be much bigger, so negative 0.6. This is x to the 6 minus 4x to the 5 plus 5x to the 3 minus 7x squared plus 1. Well, this one isn't as pretty, and let's see how many crossings do we have in here. Okay, so I'm going to try to zoom in here so you can see the green. I mean, if I zoom out, it looks, okay, so this is going to be pretty big. Okay, this is monstrous, so it just keeps going and going. Now, because it's x to the 6, what we know is that this is going to be, and it's negative 0.6, so it's going to have a maximum somewhere on top, and then it's going to be below that. Now, this is actually really hard to see, but if I zoom in here, it looks like there's a maximum somewhere there, almost at like 2,500 there, right? Let me zoom back out, all right? And let's go back to our 0, because that's what we were interested in. So our crossings of 0, so well, how many did we have? We had 1 right here, 2, 3, and 4. So that had 4 crossings. So although the order was to the 6 of this polynomial, it had only 4 crossings. And what we said is it could be anywhere between 0 and 6. And that depends on the actual polynomial itself. And this one, again, this would have been kind of hard to try to factor out. I mean, to the power of 6, you can use maybe some tools, and I know that there are calculators that try to do this numerically for you on the web, or okay, you can use something like decimals like this and try to visually see and then try to work backwards if necessary. So these are the zeros of our polynomial functions that you're going to run into. And of course, the higher the polynomial order, well, the tougher it's going to get for you. All right? But you should get a sense and understanding of what these actually mean, and also how many of them can you have. And keep in mind that when the order is even, it could happen that you might have none. Okay? And if the order is odd, you are guaranteed to have at least 1. And that goes back to understanding the range. All right, so that's all I'm going to mention in this video. I hope this gives you some intuition into these zeros. So it does stem back from understanding quadratics again. That's why those ones are so heavily studied in school, so you can now transfer them back into future polynomials like this. Thanks for watching. See you in a future video. Adios.